just make it highlight. Okay, see, they have provided you A into B plus C into D. This is the expression. Okay, for this expression, they have provided one single accumulator processor is there. So that means what? You have an accumulator in the processor. Okay, that accumulator you can use. Okay, so now assume that the processor has load. Okay, it provides you a load operation, a store operation, a multiply operation, and add instruction. Okay, so these many instructions you can use. Okay, these are all the opcodes: load, store, multiply, and add. So with all this, you can use the accumulator, and you can write a program. Okay, you have to use the accumulator here. So write the program for that. Simple program, just a 2 marks question. So how to write the program for this? A into B plus C into D. Can you try? I'll give some 1 or 2 minutes. Use the accumulator and write the code. Assembly level language code. Try it. So equation is A plus B into, so A into B plus C into D. So I'll write it here. A into B, I'll write it here. A into B, A into B plus C into D. Okay, this is the equation. You can make out here. They have clear, very, in complete information they have provided. I think you are able to see this. Okay, so we have to use the accumulator. Okay, and you should know one thing. This is according to the priority of operators. Again, multiplication will be done first, right? A into B first, C into D next, isn't it? And here it is left associativity. You know all this, no? Priority of operators. When compared to plus and multiplication will be done first. And even it's left associativity. That means even this is a star. Here also star operator is there. So which operation will be, which multiplication will do the operation first? A into B or C into D? See, be interactive. Okay, you should answer to the questions actually. Okay, so that even I can make out how whether you are doing or not and all. Please be interactive. So we have a priority wise. See, whenever the equation has been given, you should know one thing, isn't it? Which operation should do first? A into B plus C into D. Obviously, A into B and C into D will be executed first. Later on, plus will be taken place. Okay, and in that we have two operators. That is here. These two operators are both are same operators. C into D and A into D. So out of this, if A into D will multiply first or C into D will multiply first? That's what my question. See, if you provide the answer, I can make out of that you are present in the class. Otherwise, simply I can't take attendance. It's of no use, right? Taking the attendance without your presence in the classroom. Yeah, A into B will execute first. Okay, so there is 56 students are there, means all 56 students should provide the answer, so that I can make out you people are there in the class. Everybody should give the answer. Exactly, A into B will be the first because it's a left associativity, right? So left side multiplication operation will do first, then it will go to C into D. Okay, now we are very clear. Now you can go to your program writing. So write the program now. Write the program now. So you can use the operations. What operations they have provided to you? accumulator you assume, there is an accumulator. You have to understand that processor is provides the accumulator. That's one concept. And you can use, they have given that add, multiplication, MUL, and the load and store. You can use load and store. They have provided this, opcodes you can use. So now you can write the program. Write it fast. Everybody should attempt. Everyone should attempt, and everybody should give me the answer here. Everybody should write the answer here for this one. Because previous day I've already given a solved one problem to you. C is equal to A plus B. Now you attempt this one. Yeah. Yes. Okay. I'll initialize. So that you're able to, so that even you're able to go along with me. When you're trying, I think yet. Okay, let me start so that even you will get one, path on which data to take and all. See, let me take first. See, we have first we required A and B, right? A and B I required. So what I should do? I'll use load. Load. Okay. See, accumulator is here. They have provided they have provided the information very clearly. You have to use the accumulator. So load A. Okay. Load A means what? By default, I'm going to store it into the accumulator. Okay. So what is my accumulator consisting of? My accumulator is consisting of, just see here. Everybody have a look at it. So this is what my accumulator, one somewhere here. Okay. So this accumulator, I'll be having the data A. Okay, now are you clear with this? So after this, what I should do? So after loaded that, next I should take one more data. What is it? B. I'll do one thing. I'll directly add. Shall I do one thing? Add. See here, add B. Add B. So what's the meaning of this? So B will be added to my accumulator. Okay. So now add B means by default it is added to the A data. Okay, and resultant is available where? In the accumulator. Kavya has written, okay, sorry, it is multiplication. I'm so sorry. MUL. Okay, B. Sorry, yeah, I will just sorry by mistake. Okay, multiplication is. Okay, now after this, what I will do? My accumulator is having what data now? My accumulator is having the data now. A plus B, resultant data. Just a minute, my system got stuck. 1 second. It was restarted. Just a minute. You try by that time. I'm using mobile and system both. So by mistake it got restart. Just wait a minute. I'll log in. By that time you just continue. Please, everybody should answer to this question. Everyone in the classroom. Everyone should, write it. Then only I can make out you are there in the classroom. Okay. If you are able to write the program, so this kind of program, so in final exam you can expect one question 100% in the exam. It's guaranteed question. One question will be 100. You can see any question paper. You take your previous question paper. You see any question paper. There will be such kind of write a program for this instruction. Okay, so after multiplication B, see what I will do. I want to use the accumulator for further, multiplication C into D also. That is why what I will do, I will take that data from the accumulator and I'll store it in one variable, one temporary variable. Okay, keep the data into some temporary variable. Okay, then you go for C into D. Okay. So your friends has given an answers. Load multiplication, multiply A comma B, load B, B, C. Kavya has given this answer. Store Q into S. Why is such a long program, Kavya? Store Q to S. Okay. It's quite bigger, I felt, Kavya. Anyway, you have attempted. Fine with that. I just tried. Yeah, fine, pa. Good it is. A little bit extra variables you have used, I think. That's all. It's okay. Even that may give you the answer, but you have to use the accumulator, right? You have to use the accumulator. Maximum accumulator we have to use actually according to the given question, isn't it? Okay. Just a minute. I'll be writing actually. Only Kavya. Why not others? Everybody should try and give the answer, even if it is wrong. Also, okay. Nothing to worry. Yeah. So try and give your answers. By that time, I'll also do it here. One student has provided the answer to me. I want everybody to be there in the classroom and everybody should try your level best. Even if it is wrong, also okay. Nothing to worry. Yes, I'm entered. Okay, Chandrakant has given. Okay, fine. Yeah. See, as per the given as per the given question, I'll just do my work. Okay. So we have to use the accumulator maximum. That's the one thing. So my accumulator is having the value in the accumulator A plus B. I'll be having A plus B, isn't it? So now I'll be having A plus B. So what is my accumulator now? Additional data, isn't it? So both the data I'll be having on the accumulator. So what is my work? Okay, after this A plus B got over, sorry, A multiplication. I'm so sorry, I'm always use the add instead of multiplication. Okay, after that multiplication data is available in the accumulator, what I should do, I'll keep the data in one of the temporary variables. So I'll use any other memory location. So what I'll do, I'll use one T, okay, T space a temporary variable, okay, so that I can keep the data, store, store, store to C, store to what? T, temporary variable. Okay, so I'm just using one variable, temporary variable T. I've kept the resultant data. Now A into B, where it is available in T. Okay, so next I will be having next multiplication, that is C into D. So what is C into D? You know, C into D, normal multiplication. Okay, so apply the formula, apply the multiplication and just write it and instructions here. I'll just write it there. Okay, so now I'm going to write it. After I'm writing, if you feel any queries are there, you can pose here. Okay, so next thing is load C. Next thing is after load C, it's very simple. Load C. After load C, MUL, it's by default accumulator. Okay, multiply with D. Now, what is my accumulator is consisting of now? C into D. Okay, my accumulator now consisting of, okay, so right now A into B answer was there, but what I did, I've copied this data into one temporary variable. Okay, T. I've stored this data temporarily. Now this data accumulator, I'll use it for other variables. What is that? Load C. So now C will be loaded to accumulator. Now multiplication with D. Now C into D is having the data now inside the accumulator. So accumulator is having now C into D. Now what I require, C into D plus A into B, I want to do. So what I will do, already I have an accumulator data C into D. So now just I will do addition, add, comma, which data I want to add, just I want to add here T. What will happen? Add T means what? T will be added with my accumulator. Okay, so both will be available now. So final result. Okay, if you want to keep the data in some variable, you can keep the data as a resultant space. But even they have not given any destination variable. Suppose a destination variable here. Suppose here something like P is equal to, means you can store the result. Right now you don't have any any destination variable, so just I don't want to include any P or anything like this, just keep it as it is. So add T means your data is available, additional data of T with accumulator. Now your accumulator is having the final resultant data. Okay, I hope you are clear. Everybody understood? Any doubts here now? At least you line it, Bunny, you come to line and ask me, because sometimes this such kind of questions you require need a communication. So please, any doubts there, you can come to line and you can speak to me. So many are given an answers actually. Load A, multiply A comma B. Accumulator you have to use maximum, Ankita. That's the reason actually. See the line of instruction, how many I have used here? 1, 2, 3, 4, 5, 6, that's all. Any other doubts you felt you have in your mind, please come to line and ask me. We'll discuss. Please copy this answer. A into B plus C into D. Please copy this answer. Now add T. So now your data, your resultant data is available in the accumulator. Okay. So now I want that resultant data in some variable, means you can keep the data in some variable. Okay. Where you want to keep your resultant data? Where, suppose I want to keep the data in one register, one variable, you can use that. I'll write it here all because accumulator is having the data. No, so I'll make it here store. Shall I use C variable? Yeah, I'll use C. In the C memory location, I'm going to keep the resultant final data. Okay, like this you can write. If you are not included this, that is also fine. Okay, so this is what the answer to my question. Any doubts? At least tell me no doubts. No, you don't have doubts. You got the problem. Hemant has written load A, multiplication B, store B. Hemant has written very good answer. See, he used the variable, store B. Very good, Hemant. I appreciated you. Very good. See what he has done, instead of T variable, he has used the variable B. Fine with that. But I don't know why you have used X. That I didn't get to you. Everybody got at least now? What I have done, I have taken A. Okay. So by default, in the right side, which variable is there? Can you tell me what is there in the second operand location? Which is the second operand? By default, in load A, comma, what is the second, operand by default? Suppose I'll write here load A. What is the second operand? Can you tell me? Yeah, accumulator it does. So I want everybody should answer. Sahil, Medini, Muskan, everyone should answer to the question. Jeevan, Raju, Jayam, Ishan, Harsha, everyone should give the answer to my question. Okay, load A, comma, by default accumulator we will be having. Okay, now. In the similar manner, suppose I will use the word store here. Something I'll use store C. Now tell me what is the first operand now here? Store C means which is first operand? Second operand is C. This is something like this. Store C means by default it's like this. Load means by default, if I use accumulator, by default it is A comma. Please remember this. Okay, you require this knowledge. See, Load a comma. If you're not writing comma also, by default, second operand is what? Accumulator. Okay, this is always second operand is accumulator. But in store, please remember this concept. Always your first operand, even if you write store C, by default, it assumes that here you have an accumulator. Your first operand is accumulator. Please keep it in your mind. Okay, now? I hope you are clear with this concept. Everybody clear now? And this problem have you taken? This program have you taken? So here, instead of store T, I can use B only. Okay, if you want, ma'am, I don't want to use B. T means you can use here B. Okay, store the data into the B, and here I can use what? Add B with the accumulator. So we will be having the B. You can use B. Fine with it. I think you don't have any doubts right now. Now I'll give you one more problem. Let me tell you. Let me give you that. Let me give. I want answer from your side. Simple problem. See here. P plus Q. Okay. Multiplication. I'm writing something like this. So you are able to understand. This is purity wise. P plus Q multiplication. R plus S. Can you give me the answer for this? Same. Here also accumulator you have to use. Can you give me the answer, everyone? Take a book, pen, write, whatever you have understood, type it here. I'll take that as your attendance. Whoever will type the answer, I'll take that as your attendance. And while you're writing, you got any doubts, please come to line and ask me. Yes. Okay. Yes. Okay. Manasa has given some answer. Chetana, Chandrakant, Hemant, Jayam, Rakshit, Lavanya, Ananya. Okay, Rakshit has written in some order. Okay, would be add Q. Okay, resultant he has stored in one variable. Okay, temporary variable. Okay, next to load or add as location here. Very good. Yes. Yes, correct. I think I've checked with Rakshit. 100% correct. Many are writing the answer. Very nice. Yeah. I think we are using. I think people are using different variables. Different as a temporary variable, they're using various variables. That's all. See here, I think Apurva is using Q. Okay, but here Rakshita has used A. Okay. If you use the existing variable, location only, that's fine. Rakshit, what I want to say, you have used store A, no. So instead of using A, another variable, another memory location, you use Q only. That's fine, actually. Space will be, efficiently utilized. That's what I felt. So many have done that. So here, Medini has used to store C. Yes, okay. Yeah. You are writing. I think you're clear with the answer. Okay. So P plus Q R into S. So I'll write my my solution here. It's very simple. Load P. Very good. Load P. Add Q. What I will do? I will use the same variable Q. Okay, from accumulator, I'll take the result. Store. From accumulator, I'll take the result and I'll copy it into Q only, Q variable only. Okay. Over. Next is I can take R. Okay, so load R. Then I can make add Q. Sorry, yes. Valid. Now my accumulator is having the result R plus S. Okay. Suchita.
Thank you. रात दबे दबे तेरा
Suchita. I think she has muted. Yes. Okay, add S. Now S will be having the data. Now accumulator is having R plus S. Just store the data. Instead of storing the data, accumulator data, I will multiply with my Q. Multiply with Q. MUL Q. So my data will be there. Q will be multiplied with my accumulator data. So I'll just store the data into Q. See, this is the way. If I want, as many were given that answer. Okay, so my Q is having my final data. Okay, you can check it out. Even n number of answers, fine. Somebody has used another some variables. Okay. Anyway, fine with it. You can copy this also for your assignment. Okay. So I think there will be clear with this particular answer. I'm not telling this is the exact answer. You can use any variable over there for as a temporary variable, and you can write the answer. Fine with it. Okay, I think shall I take another next question? Shall I go to next question? Okay, isn't it? Shall I move on? Yes, I'll move on to next question. Let's see what is the next assignment question. Okay, just copy. So many answers I write. No, I'm just provided to you. I want to open. Just a second. Assignment, right? Yeah. Yeah, if no further explanation, I'll just give you the page number. That's all. Okay, some concepts which I've already clearly explained. I'll just give you the page number. You can go to that page number. I think you're able to see. You are able to see this. Not it. Okay. Entire screen share. No. Okay, I think you are able to see now. Okay, next question. Fourth, see, I think fourth year we have done. Then what is performance measurement and explain the overall spec rating? Isn't it? This answer, I think you know. If you want, I'll give you the page number, spec rating and all. So go to page number. Page number you can take down 17 and 18. You have in 17 and 18. 17 and 18. Okay, take down that page number 17 and 18. 17 and 18 page number you can take down. Please note down that 17 and 18 page number. Want me to show that? 17 and 18 page number. If not, I'll just show to you that answer where it is available. Okay, here we'll be having 18. Go to page number 17 and 18. Are you able to see this one? This you already know, no? Spec rating. How to calculate the spec rating? This formula, spec rating is equal to running time on reference computer, running time on a computer under test, isn't it? You know already, right? This one. So this one you have to, what is spec, you have to explain. So that is available here in the first page. What is performance measurement, that you have to explain. After that performance measurement, you have to explain this formula. See, in notes you have very clear answer. Okay, go to notes and you can make a note of it. Somebody type here that particular page numbers, so that anybody who is not able to hear my voice, they can take down that. Okay, so you can type 17 and 18 page number. Yeah, fine with it. So next assignment question, next question. So I'll take the next question. Yeah, next question will be, yeah, see what's perform over. Next, a program contains 1,000 instructions. See, this is the question. Just see here. 1,000 instructions actually. By mistake it was not printed as only 1,000. Out of that, 25% of instruction requires 4 clock cycle, 40% of instruction requires 5 clock cycles, and remaining requires 3 clock cycles for execution. Find the total time required to execute the program in 1 gigahertz machine. So please see here, everyone, please have a look at this question. So this is performance. You have to give total time taken. Okay. So for time taken, you know the formula. What is that? T is equal to N into S divided by R. Isn't it? We know that formula, right? So we have an N here. 1,000 is your N value. I'll just make a note of this. Can make out here. We'll solve the problem anyway simultaneously. Just make a note of this in your book. Take this value. Okay, 1,000 is your N. Okay, so I just make it highlight 1,000. Okay, and N into, see, S means average number of instructions, and then instructions there, how much time they will take to execute. Okay, so that's given here very clearly. 25% of instruction requires 4 clock cycle, and 40% of instruction requires 5 clock cycles, and remaining remaining requires 3 clock cycles. That means what? 25%, 40% is 65. Remaining how much? 35%. 35% requires 3 clock cycles. So that is what your S they have provided. Okay, divided by R. What is R value? R is nothing but what? Your the speed of your processor, right? So that is in gigahertz. 1 gigahertz they have given. Okay, so this is what the data they have provided. So these 3 values you have to note down in your book. Have you note down these values? Okay, so what is the value? N is equal to 1,000, that you should know. And for S, 25% of instructions required 4 clock cycles, and 40% of instruction requires 5 clock cycles, and remaining 35% requires see to this 3 clock cycles, and R is given 1 gigahertz. Okay, so everybody should take down these values. After these values you have taken, we will go to the problem. I'll solve the problem. Simultaneously, you also copy along with me. Okay. You're getting my words? So this problem answer I'm just giving you. We'll solve the problem simultaneously. Okay. You also solve the problem. See, first you should know given. What's given? That you should write it here. Given. What and all they have given? What and all they have given? You're taking no, and my voice is also audible, right? No problem. Any doubts, any problem, you just pose a question there. Okay. So given what they have provided, N is equal to. So N is equal to, what is the value? 1,000 instructions. Okay. And for S, they have provided the information. What's the for S? For S, just consider for S what they have provided. 25% of instructions. 25% of your instruction requires what? 4 clock cycles. 25% of instructions requires what? 4 clock cycles. 4 clock cycles. Okay, and out of that, what is one more value? In a 40% of instructions, 40% of, if I'm writing a INST, you have to write instruction completely. Okay, requires how many clock cycles? This is 4 clock cycles, right? This is 5 clock cycles. 40% requires 5 clock cycles. Copy this answer, okay? Clock cycles. See if there is any modification to this answer. If I made any mistake while I'm calculating, I will provide you the correct answer. If I'm mistake by this time, still I'll provide. If there is any mistake, probably no mistake, I'll check with all the sources, then only I'll provide the answers to you. Still, if I feel any modification, I'll provide you later. Okay. So now you just see 25 plus 40, 65, 65, 7, 35. Totally it was 100, 1000 instructions. Okay. I think you have taken this, isn't it? So next, what is my R value? What is the R value they have provided? That also you should make a note. Yeah. This is R value. R value they have provided is 1, just a part, 12, 1 gigahertz. So take down that 1 gigahertz. Take down that 1 gigahertz. Enter. Capital R. There also you can use capital S. Okay. Okay. R is 1 gigahertz. So please take down this 1 gigahertz. Okay now. So we know that. What we know? We know that. We know that. What we know? Performance equation E is equal to N into S divided by C here divided by R. Okay. Now we apply the values over there. Okay. So just apply the values over there. Just see to it how I'll apply the values. Everybody please take down this. It's the final answer. T is equal to, and you should calculate the answer to me. We have to provide the answer for me. Okay. T is equal to 1000. Okay. 1000 into C. S value is out of 25%. See, 25% means what? 25 divided by 100. Okay. 25% means what? I can write 0.25. Is it okay if I write 0.25? 0.25 requires how many clock cycles? 4 clock cycles. Okay. Plus how many instructions? 40%. So 0.4. Okay. Requires how many clock cycles? 5 clock cycles. Okay. In a similar manner, plus 35%. That means 0.35%. Okay, 0.35 in percentage means 35 divided by 100. Okay, so requires 3 clock cycles. Okay, I think this is over. So finally, okay, this complete value divided by. So that's why I'll put one bracket here, so you won't get any confusion. You can calculate the value and you can give me the answer clearly now. Divided by 1 gigahertz. Just here, divided by 1 giga. 1 giga means what? Giga means what? 10 to the power of 9. Okay, isn't it? 10 to the power of 9. Okay, so I will write here giga only, 1 giga. You use the 10 to the power of 9. Otherwise, I will also use it 10 to the power of 9. 10 to the power of 9. Small. Okay, this is 9. Okay, so now calculate and give me the answer. I want everybody should attempt this. Values, everything I only written here. Everybody, please solve it. Okay, solve it. Everyone is solving the answer. Yeah, very good. Chandrakant has given the answer. I'll see now everyone, whoever give the answer, for them I'll give attendance. Muskan, no answer. Medini, Shruti, Vishwajit, Hemant Reddy, Karthik, Yes. Nagendra. Yes. Yes. Very good. Chetana. Mm, Chirag. Ra. Your assignment question only. If you solve now, the test will be easy. You can easily write. So if you solve this process, such kind of problems in exam, in whatever the problems they'll provide, you are able to write, right? Yeah. I think many were given answer. Okay. You also type by that time. I'll write it here. So the answer is 4 point. It was something like 4050 na 4050, right? 4050. Okay, right. This is actually 4.05 microseconds. Micro means what? 10 to the power of minus 6. So, see, just see here, this is 10 to the power of 9. So this becomes hertz. Hertz means what? Per second. So per second I'll take up means this becomes seconds. So for that only I've written here explanation. What is it? So 4.05 microseconds is the answer. Microseconds, that is nothing but minus 10 to the power of minus 6 seconds. Okay, this is the final answer. I think everybody has got the same answer, right? Everyone has got the same answer, I think. Yes. Okay, so take down this answer. Then I will go to the next assignment question. Okay. So take down the first. Everyone, first take down that problem. Yeah, I think everybody has taken the problem. So I'll go to next assignment question. So that's very simple. So I'm going to explain. Actually, I have already taught in the classroom. So we'll go to the question assignment. Next is yes. I will go to next question. Just screen share it. Yeah. Yes. The next question is very simple. What is the need for addressing modes? Explain all the addressing modes with example. Okay. So this is the question. So just go to the page number. See, it's provided in the notes. Okay. In notes they are very clearly given. But still, I'll show you the page number 48. From 48 it will start. Okay. So immediate addressing mode. You know all the addressing modes I've already done in the classroom. What is the immediate addressing mode? Register addressing mode. Absolute, indirect. I'll just make it. Yeah, so here base with index, base with offset, relative, auto increment, auto decrement, right? So they say, so all that you have to explain in brief. Okay, so it's completely 10 marks, so no AB. Every so they've given very clearly. Okay, so go to notes. They've provided all the very neatly. They have provided in the notes. So just copy from that. Just study in textbook also. Okay. So clear with this. So page number, if you want, you can write starting from 49, 49, 50. It will be many pages are there. 49 and onwards. Okay. So that's the thing. Next question. What is stack frame? So stack frame I have already explained, right? Yesterday only I have explained the stack frame. So if you want, I'll give you the page number of stack frame. So go to page number. See, the stack frame is there. So page number 75. Somebody type that, okay? So page number 75. You have that. In page number 75, we have that answer. You have to explain that in one diagram you have to write. Okay, so that is available here. Just see to it. Yeah, this is the stack frame diagram. Okay, so you have to write this diagram very clearly. See the subroutine stack frame. You have to see to it, and uh, the stack frame is here. The stack frame you have to explain, and that diagram you have to give. Okay, that is what stack frame. I've explained you that FP is there. No FP, SP, everything you have to explain clearly. Okay, you got that answer. If you want, somebody type it as page number 75. Page number 75. Okay, type it there. Anybody? Please type it so that everybody can note down that. Yeah, okay. And the previous also, I've told the page number, no? That also you just type it over there. Next one is, I take next assignment question. If I feel I want to explain that, then I'll explain it. Shift and rotate operation. See here, just see the shift and rotate operations. So what are the shifter? Arithmetic shifter, logical shifter. Okay. So rotate. What? Rotate left with carry, without carry. So that answers you have to write. So suppose if you want me to show that, I'll just show it here. Page number for that is click on that logical shift. Yeah. Page number 82. Page number 82. So I'll take you there. Page number 82. I think you're able to see this. Shift and rotate instructions. Okay. Shift and rotate instruction. Logical shift with left. Logical shift with right. Okay. So like that, arithmetic shift towards right, towards left. Okay. Next, rotate. See here, logical and arithmetic shift instructions. This you have to write the diagram and explain. And similarly, arithmetic rotations with carry, without carry. These diagrams. Okay, these are all very, very important. Then you have to take this example and you have to explain. Okay. That is with respect to that. So in exam, it could be a 10 marks question. They'll explain the logical shift and rotate operations. So completely 10 marks question. Okay, so then you just make out how much answer you are supposed to write. Okay, so like that. And after that, we'll go to next assignment question. If you want page number, if you want, you just type it there. 81, I think, right? 81, 82. 82 page number, it will start. You see the notes is available. No, in notes this answer is there actually. Okay. Okay. I think next I can go to next question. See here, the register R1. This is R1. Okay, sorry, it is R1. Please make a change here. This is R1 and R2. Register R1 and R2 of the computer contains the decimal values. See, contains the decimal values 1200 and 4600. Okay. So what is the effective address of source operand in each of the following instructions? See, very clearly they have given. You have to write the effective address of source operand. Okay, which is source here? This is source. What is its effective address? So what is the effective address of this? What's the effective address of this? What's the effective address of this? What's the effective address of this? That's all. Okay, so we'll take that. First thing is, so I'll just take this load 20 of R1 R2. Take down this problem, everyone, and write the answer. Provide the answer for me. See, in R1 and R2, please make a note of this. What is the content in R1? 1200, 4600. These two values. I want you to do this problem. Now, just you have to give the effective address. First one, what is effective address of first one? First instruction, what's the effective address? Type it. Okay. Waiting for your answer. Attempt first from your side. Yes. Yes. Everybody is typing. Okay, I'll solve this. Okay, for this we are supposed to write the answer, right? And here, and R1 and R2 register, right? So what is R1 value they have provided? R1. What's the R1 value they have provided? R1 value is 1200. What is R2? R2 they have provided us 4600, isn't it? Okay, now. So here you have to write the effective address. Effective address of what? So they have given in the question very clearly. Effective address of first operand. They have asked everywhere first operand, right? Only the source operand. They have asked you to give the source operand. Effective address of source operand. This is the question, right? Is equal to what? That's the question. Okay. So we'll take first one. So for this effective address, we'll take the effective address of this. Just write it here. So EA means what? Effective address. So EA is equal to, so 20 plus, right? 20. So content of R1. See, content of R1. So how to write that? Plus content of R1. So content of R1 is like this. What is content of R1? 20 plus. What is content of R1? Content of R1 is 1200. Okay, that will give just 1220. This is the effective address. Okay. Next one. I'll take the second one. I think this is the answer for first one. So I'll take the second one now. Second one, effective address. See source. See here, effective address. No effective address here. Why no effective address? Because you have a data. Your source operand itself is data. So I'll write it here. No effective address. No EA. Why it is no EA? Because source operand is immediate. Source operand is a data itself, is a data or operand itself. So I don't want the location information. Okay, that what it indicates, data or operand itself. Write it in your own word. Okay, no need to copy the same thing, but no effective address for this. This is just copy it here. No effective address. It's immediate data. Okay, you can write it here, immediate data. Immediate data. Next, effective address. Effective address is equal to, what's the effective address for this? See, RS2, this value. Okay, this is actually not RS, this is R5 actually. It's mistake. By mistake, it is RS actually, it's R5. So, what is the effective address? R5 only. Okay, suppose I will ask you what is the effective address of the second operand, means what you should write? Second operand I used to ask this, you have to write like this. What is that? 30 plus R1 content plus R2 content. Okay, content of R1 plus content of R2. So, our content of R2. This is what actually for your second operand effective address. Okay, so right now it is not required for me, so I'm not writing this. I'll delete this. Is it okay if I delete that? Yes, I'll delete this. What's the effective address? R5 itself. What's my R5? Do they provided the R5? They're not provided the R5. So just write it R5. That's all. Okay, pa? R5 value they have not provided, so just keep this data as it is. Next, I'll take the next question. It's fourth question. Effective address EA is equal to, see here, pre-decrement. Just see here, this is pre-decrement of R2. Okay, what's the pre-decrement? Decrement the content of R2. Okay, so what's your R2? R2 is 4600, isn't it? See, R2 is 4600. So I'll just make it 4600 minus 1. Pre-decremented. It could be -4, it could be minus some, depending on various word bytes. So right now, I assume it's only the decrementing by locations will be decremented by 1 locations. That's why I've taken this 4,000, 559, 599. Okay, is it correct? See, any mistake, please message me, okay? Sometimes while we are writing, we may be doing some mistakes, okay? Next, effective address EA is equal to, see here, see they have provided comma, okay? Small mistake, R1 plus comma R5. So effective address of R1, okay, what's the effective address of R1? Content of just here, content of R1. It is post decrement, so please don't increment now. Effective address is just content of R1. What's the content of R1? 1200, that's all. Okay, this is post increment. So content of R1 itself is my effective address. I think I've given the answer to you. Any doubts you have? Doubts in Rappa? Any doubts you have? Everybody copied this? Any doubts?
Ma'am.
Yeah. Tell me, Pa.
In the third question, the value
Yeah,
of
third
R,
question stuff. Yeah.
should we consider the R value in the like, do we need to consider the value of one and they can be related?
Yeah. See, I don't know what is R5. Okay, I don't know what is R5. But see, I'll assume like this. Suppose if it is store R5 to, this is source, this is destination. What is the, where you will go for R5? So suppose I'm going to take the value from R5 and keep the data into 30 of R1 comma R2, isn't it? So now R5 is where I will go. This indicates go to R5. Go to R5 location and take the content of that. Go to R5 register, that's all. Okay, so I'm writing directly R5, that's all. If you want,
I understood that, but like suppose the value.
Suppose R5 you have a value na. Okay, Medini, I have understood. I think so. I think who is asking the question? Whose voice it is? Ananya. Suppose instead of R5 you assume R2. Ananya. Shall I take R2 here? Suppose I'll take R2. Okay, just here instead of the same question, I will take store R2. Is it fine if I take R2? Okay, R2 comma some value. Okay, just R2 comma some value. I will take R5. Assume it's an R5. Now we want the effective address of R2. Just here, effective address of R2 will be R2 only. Effective address is equal to R2. Go to register R2. That's all. Suppose if it is something like this, within the bracket it is something like this. See, effective address means what? We are supposed to get the data. Where I have to get the data? That location you have to give. That's all. Suppose if it is store within the bracket R2 comma R5 means now effective address here it will be changed now. Now the effective address becomes effective address is equal to just here content of R2. What's the content of R2? You know the content of R2. What's the content of R2? 4,600.
Yeah.
I think you are clear now. Exactly right. This by this explanation you are able to understand. I think.
Yes. So I'm asking suppose content of R5.
Yeah.
What
R5.
would be it?
If the content is R5 is there. Yeah, I'll add here R5. I'll assume here some 4,000. Okay, now same thing. Just right now R5 is equal to 4,000. See, R5 is equal to right now. See, just see here. R5 is equal to don't write now 4,000. Write it R5 only. Content of R5 is 4,000 pa. If it is bracket like this, see here I'll write Ananya. R5 now within the bracket means write the content effective address is equal to content of R5 that is equal to 4,000. Now, if there is no content, just keep as it is. Go to R5. Effective address is equal to R5.
Okay.
Okay. See, I'll do one thing, pa. I'll go to this big blue button. There, I will take example. Here in Word, I can't write it. Everybody copied, no? Everybody copied this answer. Shall I go to that? I'll go to big God. Just be there, Ananya. I will take you there. Here I can't write. Okay, that's why. Now I'll take you there. Okay. So your friend is asking this question. Okay. Suppose here, as per Ananya question, suppose add R5, comma, some location. I'll assume it is R2. Okay, now here they have provided R5 is equal to some value they have already provided. What's the value they have provided? R5 is equal to. I'm giving new example. Okay, for Ananya's question. R5 is equal to, assume it is 4000. Okay, now just have a look at this. I'm writing here some register. What's the name of the register? Name of the register is R5 here. Okay, inside this R5, I'll be having a data. What data I'll be having? 4000. Okay, this is what my content. Now, here the question is, I want the source operand R5. Where I should go? I should go to R5. That's all. Okay. So what is my effective address? Effective address means what? Your location of your data. That's all. Where is your data exist? In R5. You have the data, that is R5. So go to R5 and there you have your required data. That's all. Okay, this is what. Suppose I want the, something like this, R5 within the bracket. Then effective address is just here. Then the effective address is equal to your content is available. Your content is available. Now see, Ananya, your doubt will be clear right now. Just see to it. Now, effective address is equal to, within the bracket, I have R5. Okay. So now you go to R5, this guy, you go here, there you have some data. That data will provide you the location of your content. Now just see here, I will go to R5. So what's R5? R5 is having 4000. Take this data. Okay, that is what square bracket tells. Go to 4000. What data you'll be having? So I'll write here some 4. I'll write here 5. Okay, so this is what your content. Okay, your effective address is 4000. Inside that content is maybe 5. I don't know what data it could be. It just neglect that data. Okay, but effective address within the bracket means, okay, here within the square bracket, what is it? Small bracket means it indicates pointer. It is R5 is having some content. Go to that content, that will give you the data. That's what location indication. That is what effective address. Effective address will tell you the location where your data exists. Okay.
Yes.
I hope by this. Yeah. Okay. I think with this example you are clear. I think go to 4000. In 4000 you have that data location. Okay. Suppose it's only R5 comma R2 means R5 is your effective address. Within that R5, whatever the data is there, that is your data. I'm not bothered about data. I'm speaking only a bit about effective address. Okay, now, Ananya? I think, okay, I hope she has understood. Okay, anybody have any other doubts? During addressing modes, I have explained. We can't add 1200 in first queue. Which one? Which problem you are telling? 1200 in first queue. Purva, your question is which question you are speaking? Question, which question? 1200. Which one, Apurva? First question. We can't add 1200. Which one? First question, na?
First sub question.
Fourth?
First sub question.
First sub question, na? Load 20 of R1, RS, that question, na?
Yes, ma'am.
Yeah, 20 plus you have to add 1200.
Ma'am, there 1200 is address of another value, ma'am.
See, okay, I'll write here, pa. See, it is given as load. Can you read that question? Load. What's that question? Load 20 of R1 alpha. This is 20 of, right? This question now you're talking about. Yeah. Is this question on Purva? Yeah. Yes. Yeah. Very good. See here also see the effective address. Just see. I think you're a little bit confusion about effective address. Effective address means it will give you the address of your data. That's all. Okay, it will give you the address. You go there, you will get the content. That's all it tells you. Okay, so effective address. Okay, so I want the first operand. So I don't know what's the first operand. So I'll write it here. Register R1. What's the content of register R1? Very they are only given. What's the content of R1? R1 is 1200, right? So this is 1200. Now, see, this is within the bracket. Just see it. This is within the bracket. 20 with R1 is different. Suppose if it is only 20 with R1, okay, so that's totally different. This is 20 with small bracket of R1. So what it tells, so 20 is there. So 20 plus you have to add something. Okay, so this is actually indirect mode of addressing. So there is you have R1. So this is you go there, some content of R1 is there. No, in that location, whatever data is there, that is what your location address. Okay, take that one. So, go to R1. Yeah, R1 I went. So 1200. This is what. This is not my content of this location. This is not the content. This is not the content. So what I'm just giving you effective address. So 20 plus. So go to this R1. You have 1200. I'll take this 1200. So what does it will provide me? So it provides me the answer 1220. Okay. Now go to 1220. This is the effective address. Somewhere here. Okay. Somewhere in the memory 1200. You have some data. What data? It may be X. That is what your effective. That is what your data. Now load X to R5. So now what is my R5? Can you tell me now? Somebody tell me what is my R5 right now? ಈಗ ಆನ್ಸರ್ ಏನಾಗುತ್ತೆ ಅಪೂರ್ವ? Load X comma R5. Now R5 becomes what? X. See, R5 becomes X now. You're taking, so effective address give you the location, not data. So go to this 1200, you have some data. That the data is your first operand. Okay, so now my question is only effective address. I'm least bothered about content over there. Okay, so this X will be copied into R5 now. So X will be copied into R5 now. So that's what I've done. So what's my R5 now? Instead of 4000, now it has been changed to X. I hope many were understood. Okay, fine. Okay, effective address I'm talking about. Anybody have any other doubts? Okay, suppose I'll take one more last one. I'll take with it. Suppose I will take here on the same example only I'll take add. What is that? Add minus of, just here minus of R2. So this may clear many students doubt. I think R2 here R2 comma just here comma R5. This is the question, right? Everybody have a look at this. Add minus of R2. So minus of R2 means I want the operand here. No, what's the operand? I don't know what is the operand, right? R2, they know that what's the content of R2. So content of R2 is, I'll write it here. Is it okay if I write it here? I have a space here. So R2 content will be provided. What's the R2 content? R2 is 4600, isn't it? 4600. I hope you are clear with this. Okay. See, just see here. See, this is within the small bracket. It's indirect mode of addressing. Go to R2. See, I'm not at all in the matter of content over there. I'm in the matter of effective address. I want the address of my first operand, where it is available. I don't know where it is available. Right now, I don't know where it is available. Now I'm finding. So minus of R2 within the small bracket. So go to R2 within the small bracket means content of that will provide you the address, location of your data. Okay, so R2 I'll be going. So what's the data now? 4600. I'll access the data. Okay, so 4600. So 4600, I want to decrement it, pre-decrement it. Pre-decrement means what? Now only I should decrement first. I'll decrement one value. Okay, so what's that value now? 4599. Go to 4599, where it is somewhere in the memory. 4599. I have some data. What data I'll be having? I don't know what data. For that purpose, I will write here Y. Okay, Y I will write. Now tell me what is the content of your first. Now what is the data available in R5? Can you tell me? Yeah, Karthik, 1 second. But what is my content of R5 now? Very good. Content of R5 is what? So I went to this effective address 4599. I got Y there. So that Y I added with my R5. I don't know what's the content of RY. Assume it is 0. Assume it is 0. 0 plus Y is Y. That's all. Clear now? Clear with my effective address? So like that, auto yaudappa ನೀವು ಕೇಳಿದ್ದು auto decrement. Auto decrement ido. This is only auto decrement. Karthik, whatever I explained, no, this is auto decrement only. Okay, this is only auto decrement. And auto increment is there. Auto increment, you want me to ask, I think, right? Not auto decrement. Auto increment is here. See here, subtract R5. There's one more equation, last one, I think. See here, I think it is last one. Subtract. See, this is R1 plus. There is not like pre-incrementing is not there. It's actually post-increment only they have provided. Plus, comma, R5. Now I will ask you the question now. Okay, so you have to give me the answer. What's the content of R5? Now I will do it first. R1, see, go to R1 now. I want this data. I don't know what's the data. I don't know what's the data here. But I want the address. Where is the data exist? So that is what my effective address. What's the effective address now? So R1 plus it's post increment. Post increment means what? After I am access the data, you have to increment it. So just now your post increment is nothing but just R1 is the location of your data. So content of R1 because it is within the small bracket. So content of R1 is what? Content of R1 is what? How much it is? R1 though 1200, right? 1200 is the effective address. Go to 1200. You have some data there. No, go to 1200. You have some data over there. That is what your first operand value. So can you tell me what's the value? The data will be stored in R5. Assume that R5 is 0 now. So subtract first operand with second operand means what's the content of R5? Can you tell me now? ಈಗ R1 ಅಲ್ಲಿ 1200 which data ಇದೆ 1200 ಅಲ್ಲಿ the data will be provided is X here. X minus, so R5 default it will be empty, so 0 it is. So R5 means R1 means 1200. In 1200 we have X minus 0 is X. Very good. That is what effective address. I hope you're clear what is the effective address. Everyone? Okay, ma'am, should we decrement with 4 or any? Yes, sir. Yes, Akanksha, you can decrement 4. Suppose your word, okay, your memory word is usually 4 words, so it will be decremented by 4 only usually. 4, 8, like it will decrement by 4 usually. But here they are not mentioned. No, it is not. One word is equal to 4 byte or 32 bit. They are not provided any information. That is why I am decrementing by only 1. If you decrement it by 4, it's not a wrong answer. You can write that also. Yes. Okay. I think many of you went through the problem, understood, I felt. Okay. Okay. Even if you are not understood, it's okay. Fine. Take this problem and you have to trace it like this. See, in Word, no, in Microsoft Word, I can't, explain. We have to write the memory like this. See, you have to write the locations like this. If I write the locations, you're able to understand. Okay. So I felt here writing like this was, I want you to make understand this. I should use like this only. Without writing, no, you're not able to understand. Yeah, I felt everyone has understood the concept. Any other doubts? Okay, last one question. I'll show you that. By the 7th question, I'll complete. Remaining, we'll do it in the next class. Okay, fine with that? Yeah, I'll just take last one assignment question. Okay, that's left with I think C or B sub question. I think. Yeah, it is 7th B. It is 7th B is write a neat diagram and describe the input and output operations. So input and output operations. So where it is available? Show you the diagram. Okay. Yes. So this one, I think page number, go to page number 65, 64, 65. Yeah, I'll just show you that. 64 and 65. Yeah, you have to write this diagram and you have to explain. 64 and 65. This diagram, pa. Specification for processor, keyboard and display. Okay, input is keyboard and display is output. Okay, so you have to explain this diagram. Okay, you have some data from here, input output organization. So here you have to take this diagram. Page number baritira type ಮಾಡಿ ಯಾರಾದರೂ ಒಬ್ರು. Somebody please type that. Page number 64, 65. You have to write this diagram. Okay, and explain properly. Okay. So notes, in the notes they have provided the answers. You can copy from there. Okay. Then remaining questions we'll solve it in the tomorrow's class. I think 7 questions already completed and only 8, 9, 10, 11, 12. Only 5 questions are there. Today we are supposed to, do the problem and all, so it took much time. Okay. Tomorrow we'll take all the remaining questions and we'll complete. Okay. Any other doubts? You just put a question over here. By that time, I'll take attendance. Yeah, I'll call Asta. Please use microphone. I think Asta is not there in the classroom. Okay, Asta is not there.